Okay, hi 3-1. We're going to move on to the next part. Okay, now we're going to look at the fourth method to tell whether or not a substance is being oxidized or reduced. Okay, and if a redox reaction has occurred. Okay, so now if we were to look at page 4, okay, basically I'll start off with a definition of oxidation state. Okay, some students think that they are the same as charge, but they are not the same. Okay, so basically oxidation state, if you look at this table here, okay, oxidation state, okay, can you add on oxidation state? Okay, you write here. Okay, oxidation state and charge. What is the difference? Okay, for oxidation state, okay, I'll write it bigger. Okay, so for oxidation state, okay, this one will be the sign first. Okay, that means plus or minus, then number. Okay, whereas for charge of an ion, okay, it will be in terms of number, then sign. Okay, which you have seen in the slides that I've given to you. Okay, so take note of that. Okay, so there are 4 rules to help you to find out whether or not, okay, to find out what's the oxidation state of an atom. Okay, if it were to exist as an ion. Okay, so first thing is if it's an element, can you kindly take note element? Okay, so first rule is for element. Okay, the oxidation state will be 0, very simple. So if you look over here, alright, all these are elements. Please take note, all these are diatomic molecules, they are also element. So if I'll use a different color, you can just put a 0, it's like a power. Okay, neutral, because they are elements, that's what you learn. Okay, under atoms, molecules. Alright, now next, rule number 2 is for simple ion. Okay, when we say simple ion, okay, what does it mean? That means it consists of only one particle. Okay, or one particle. Alright, so if you look at it, all these are just H, sodium, oxygen, only one. Okay, and basically the oxidation state is equal to the charge of the ion. What do we mean by this? So just now I mentioned oxidation state. Okay, sign then number, right? Okay, and it is equal. So this is a plus, so I need to write the sign first, plus, then after that the number 1. Okay, whereas when it's a charge, okay, I don't have space over there. Basically when it is charged, okay, then this is 1 plus. Okay, and take note for oxidation state, here I'm going to use a short form OS. Okay, later on when I write. Okay, so take note. Okay, now rule number 3. Okay, when it is a compound, it is only for compound. Okay, and all the atoms, alright, will add up to 0. Okay, the oxidation state of all atoms add up to 0. So if you notice here, can you see they're all compound? Ammonia, sulfuric acid. So basically what does it mean when add to 0? Okay, at the end you just put 0 to the power 0. So all of them, the oxidation state will give you to 0, as shown in the equation. Okay, now the last one is for polyatomic ion, which you learn, or we say complex ion. Okay, that means more than one particle. Okay, and it will be equal to the charge of the ion. So if you look here, can you see all these are polyatomic or complex ions? So it will be equal to the overall charge. So you notice here is equal to -1 and -2. Okay. Now we're going to move on. We're going to look at example 1 now. Okay, so now we will look at example 1. Okay, example 1 on page 4. Okay, so how are you going to calculate the oxidation state? Okay, but if you look at on top, okay, you can see elements with fixed oxidation state when they are in compound. Okay, so basically hydrogen, oxygen, group 1. group 2, group 3, and lastly group 7. Okay, so when we look at example 1, basically you are given calcium carbonate. Okay, and they want you to find oxidation state of carbon. So what you do is, you let the oxidation state of carbon be X. Okay, oxidation state equals to X. Alright, I'll write it in statement form. Okay, so let oxidation state of carbon be X. Okay, we don't know because that's what we want to find. So then you look at it now, you look at the 4 rules, which one will you apply? Okay, so can you see that this is a compound? Okay, so if it's when it's a compound, which rule do you look at? Which rule apply for compound? Is rule number 3. So all the oxidation state will add up to 0. So I want to use a different color, put a 0. Okay? Now, next, then you ask yourself, okay, I need to find unknown, so I need to find out what is the oxidation state of calcium and oxygen. Okay, then you will look at under the elements with fixed oxidation state. Now, can you see that calcium is in group 2? So what would the oxidation state be? Plus 2. Alright, and oxygen is in group 6. Okay, so will be minus 2. Okay, now with that we can form an equation. All of them will add up to 0. So now how many calcium are there? 1. So 1 calcium multiplied by each calcium has an oxidation state of plus 2. Okay, 1 carbon, and it will be X, and 3 oxygen. Okay, and each is minus 2, and all of them will add up to 0. So now we have this equation. Okay, we solve for X. So basically 2 plus X minus 6 equals to 0. Okay, so X will be equals to, now you notice here, so is, now you need to put plus 4 because oxidation state has a sign. Okay, so take note, not just 4. This will be wrong. Alright, okay.